In this section of class, we've been learning about digital sensors. We learned about the simplest type of a digital sensor, the switch. More complex digital sensors are composed of multiple switches arranged in some way that makes it useful to measure some quantity. For example, when we learned about the encoder in this section of class, we had these Hall switches which were arranged in a circle with a magnetic disc so that the switches going on and off can tell you the rotational angle. In this video, we'll be looking at one more digital sensor that you have in your kit, the matrix keypad. A matrix keypad is a common digital sensor that's used to get user input. In this video, I'm going to show you how the matrix keypad works, and I'm going to give you a setup for how to use it. But then I'm going to ask you to actually hook it up and write the code to get some user input and display it on the LCD screen. In your kit, you have a matrix keypad device that looks something like this. There's a square, and on this square there is a 4x4 array of buttons, and then there's a cable coming off of this square, and it terminates down here with 8 little holes that you could use to plug a wire into each of these 8 little holes. I'm going to show you what's happening in the circuitry inside of this device. Here I've zoomed in a little bit so that you can look at what's happening in detail. Each one of these keys or buttons is a switch. I'm going to draw the symbol for a switch here in place of the button. So each of these little pictures of a switch that I've drawn here represents one of the buttons or keys you can press on the keypad. When you press the button, this switch lever will close to close this circuit. Now, one of the 8 terminals that you have at the end of the cable coming off of the keypad is going to one side of all of these switches. So it looks kind of like this. Then there's a different wire, another one of the 8 wires that are attached to the keypad terminal, that is attached to the left side of all of the switches in the next row. So here I've drawn in the wires for all 4 rows. 4 of the terminals in the cable are connected to the rows, 1 wire to each row. Now, the other 4 terminals are connected to the right side of the switches in columns like this. So I'll use the red color to represent the column connections. Here, the red wire and the blue wire are not connected to each other. They bypass each other. In a circuit diagram, we often draw that like this to show that they're not connected. I'm just leaving that out here for the sake of simplicity, but the bypass is actually true for all of these wires. So now, how do you use this device? Here's how we use it. Each of these rows we're going to connect to an output pin on the PSoC. Let's suppose that I'm going to call this pin 1 and this pin 2. These are digital output pins. Then each of these wires that are connected to the columns, I'll connect to digital input pins. Let's call them pin 5, pin 6, pin 7, and pin 8. So these are digital inputs, and these ones over here are digital outputs. To figure out what key is pressed, you're going to go through a process of scanning the outputs and the inputs. You will start by setting all of the digital outputs low. When all of the digital outputs are low, all of the digital inputs will also be low, whether or not any user has pressed any key. Next, set one of the digital outputs high, but leave the other digital inputs low. And check each of the digital inputs one at a time to find out if any of them have gone high. Suppose that while pin 1 is high, you read that pin 6 is also high. That would indicate to you that this switch here has been closed and the number that is written on this button has been pressed by the user. Or suppose that pin 8 you've detected as being high while pin 1 was set high. That would mean that this switch has been pressed by the user. If none of the digital inputs have been detected as being high, you can then set pin 1 back to being low, and this time set pin 2 high. Check each of the digital inputs again to find out whether a user has pressed this key or this one, or this one, or this one. If none of the inputs have been detected as high, we'll then set pin 2 low, and we'll check pin 3. Set pin 3 high and check the inputs. If none of those are high, we will set pin 3 low and set pin 4 high and check again. So that's basically how the matrix keypad works and how we use it to detect a key that's pressed. Let's go and create some PSoC code. Open up PSoC Creator and let's create a new project. Make sure you select the correct device, empty schematic, and then give your workspace and project a name. I'm going to call this Sensors and Keypad, but you can name it whatever you want. Okay, here in the top design, we will start by setting up our pins. So I'll go to Ports and Pins, and we want only digital pins. I need 4 inputs and 4 outputs. I'm going to start with the outputs just because that's how we drew it in our diagram. We had pin 1, 2, 3, and 4 being the outputs, and 5, 6, 7, and 8 being the inputs. So there are my 4 outputs. And now I need to set some of the settings for these pins. We'll start with the outputs. In the outputs, the only thing you have to change in the settings is uncheck hardware connection. We're doing that because we're going to set the state of this pin in our program, not by physically connecting the pin to something else. So I'll uncheck hardware connection for all of the outputs. And then we also need to make a change to the input pins. And I'll try to explain what the meaning of this is. Instead of high impedance digital, click on this drop-down list and choose resistive pull down. The reason why we're doing this is because when the button is not pressed, in other words, the switch is open in our circuit diagram, we want the input pins not to be connected to nothing. We want them to be connected to ground so that any errant electrons that are still on the pin will be drained away to ground. Now, in the old days, before we had these nice PSoCs and everything, we would have to physically hook up a resistive pull down. We'd have to take a resistor and connect it to the pin after the switch and connect the other side of that resistor to ground. And nowadays we don't have to do that because the PSoC can actually put a resistive pull down in the circuitry for us, which is really nice. But if you forget this, you'll get some false positives on your switches. So make sure you change all of the inputs to resistive pull down. Okay, next we go to our pins. And we need to assign these pins. I don't actually care which pins you choose to use here. So set up these pins however you want. You might already have an encoder that's plugged in, and so you don't want to use the same pins as your encoder. So select whatever 8 pins are still available and not used for anything else at the moment. You might also have your LCD screen plugged in, which is a good thing to have. So don't select any of the pins that your LCD screen is using. Pick 8 available pins and assign them here. After you've assigned your pins, go to main.c and we'll clean up the code a little bit. Then, before we do anything else, we're going to go ahead and build the code. We just want to check to see if we've made any errors in the top design or in our device selection or anything like that. So wait for your build to succeed. Then, once the build has succeeded, you can also program the PSoC with this no code that we've written to check and make sure that your project has been set up correctly. So click on the little chip to program the PSoC and make sure that everything's okay and your program succeeds, and then we'll move on and write some more code. Okay, if your program has succeeded, let's write some code to read this keypad. The first thing we want to do is initialize all of our output pins as low. So we'll do pin 1 write 0 to set pin 1 low. And I'm just going to copy this line and paste it 3 more times. We want to set pins 2, 3, and 4 also low. Now let's just do a test to read one key. Here in our for loop, we will set pin 1 high, and then we'll check each of the output pins. So if pin 5 read is equal to 1, then the number that was pressed was the number 1. Let's go create a variable to keep track of what number was pressed. Let's do int number pressed. And we'll set this equal to, let's set it equal to -1 initially, because there is no key -1. So if pin 5 read is 1, that is, if pin 5 has gone high, the number that was pressed was 1. Now let's do else if. So else, that is, if pin 5 is not high, next I want to check if pin 6 is set high. If pin 6 is set high, that means that the number pressed is 2. Okay, and now I'm going to do another else. where we'll check pin 7 to see if the number pressed is 3. Then we'll check pin 8 to see if the number pressed is 4. Now we need some way to test to see if this is working correctly. One way to do this would be to output the number to the LCD screen. Let's go ahead and do that. So I'll go back to Top Design. We'll go to Display, and we'll get a character LCD. Your pins here might be different than mine. Your pins do not have to be the same here. I just have an example there. Make sure that you set the pins for your LCD screen to the pins that you actually have your LCD screen plugged into, the way we had it set up in the very beginning of the class. So select the pins for your LCD screen here the same way that we had it previously. Then, back in the main.c code, let's build the project. We often want to build the project every time we change something in the top design. That way, when we start typing in code, things that we've added to the top design will be recognized when we start to type them here. So wait until the build finishes. Then, let's make sure we start the LCD screen. And here we're going to do we'll clear the display. We'll set the position to the first row and the first column. Number pressed. Now keep in mind that if we don't press a number, or before we've ever pressed a number, it should show the number -1 on your LCD screen because we initialized number pressed to -1. But when you press one of the numbers 1 through 4, you should get that number showing up on the LCD screen. It might help to also add here a little bit of a delay. Let's say 50 milliseconds or something like that, so the screen doesn't clear all the time continuously. Now, before we program the PSoC, let's plug in all of the wires that we need. When you look at the keypad so that it's right side up for how you're looking at it, the leftmost pin of the keypad is pin 1. So in your pins here, and remember you might have set these to different pins than I did. This is just an example. The leftmost pin of the keypad should be plugged into whatever pin you set here, and then the second one should be plugged in here, and the third one should be plugged in here, and so on. Once you have all those wires plugged in, go ahead and program the PSoC and then see if when you press the numbers 1, 2, 3, and 4, that number appears on the LCD screen. If you have that working, what I want you to do is add the additional code to be able to read the other numbers on the keypad. I'm just going to give you a little hint here for how to start that. I'm going to take all of these things that we already have here, starting with pin 1, right 1, and I'm going to copy it. And then down here, I'll paste it. I'll change pin 1 right 1 to pin 1 right 0 so that we set pin 1 low. Then I'll copy this line, and this time I'm going to set pin 2 to be high. If pin 2 is high and pin 5 is read to be high, this time the number won't be 1, it'll be 5. Or actually, I see I made a mistake here. This will actually be the number 4, and this here will be the letter A. For now, let's not care about the letters. We'll add the letters later on. So this won't be number 4. This will be number 4. And then here, this will be 5. And then this one will be number 6. And let's take this one out. Here. So here you should be able to tell between numbers 1, 2, 3, 4, 5, and 6. You add the rest of the code to tell the difference between 7, 8, 9, and 0. If you want to add the characters, go ahead and do that, but I just want to see that you can identify the numbers.